Hi, in today's session we are going to cover multiple topics of number systems which are very small topics but very important to understand. So we will be covering estimation and round off, factors and multiples introduction, divisibility test and coding decoding. Let's start by estimation and round off. Now first let's understand how to find a nearest number. Let's say we want to find a nearest number in tens. Now what do we mean by tens? If you remember place value chart, we learnt about units, tens, hundred, thousands, different places that we give to the digits of any number. So when I'm talking about tens, I'm talking about any two-digit number that ends with 0. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Fine. If I'm talking about hundreds, I'm talking about any three-digit number that ends with 00. So 100, 200, 300, 400, 500 till 900. Okay. Now if I have to find a nearest number in tens for a given number, we just look at the two digits that are at tens place and units place. For example, here we have a number 52. So we will think 52 is between which two round figure numbers in tens. So if I think about all the round figure number in tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, we know that 52 will come between 50 and 60. Now we know 52 is just 2 steps away from 50, whereas it is 8 steps away from 60, right? So that means 52 is more near to 50. So the nearest number in tens for 52 will be 50. Let's take one more example. 59. Now 59 is more near to 60. I'm taking the same number from the same series. 59 also lies between 50 and 60, but it is more near to 60. It's only one step away from 60. Correct. So nearest number in tens for 59 will be 60. Now let's say we have been given a three-digit number, 122. But we have to find the nearest number in tens, not in hundreds. Okay. So we will only look at 22, not 122. 1 will come as it is. So 122. So 1 will come as it is. So 122. So 22 lies between again 20 and 30. See, 1 comes as it is. But 22 lies between 20 and 30. And 22 is more near to 20. So answer will be 120. So nearest tens for 122 will be 120. Right. Let's take 148. Now 148 again 1 will come as it is because we are not concerned about hundreds over here. We are talking about tens. And 48 comes between 40 and 50. But 48 is more near to 50. So it will get, so the nearest number in tens for 148 will be 150. Now let's say we have to find the nearest number in hundreds. Again I am taking the example 122. This time we are talking about hundreds. That means we'll have to look at 1. Right. So 122. Now I am talking about hundreds. So 122 lies between 100 and 200. But it is more near to 100. So the nearest number in hundreds for 122 will be 100. Let's say 245. 245 is more near to 200. 245 lies between 200 and 300. But it is more near to 200. So the nearest number in hundreds for 245 will be 200. Right. So let's take more examples again here. 84 is more near to, so 84 lies between 80 and 90. So 84 is more near to 80. Whereas 93 lies between 90 and 100. So, but it is more near to 90. Similarly, 167, we'll not look at 1. 1 will come as it is. 67 is more near to 70. In 162, 62 is more near to 60. If we take 359, 359 is more near to 400. Now 359 lies between 300 and 400. Correct? But it is more near to 400. So the nearest number in hundreds for 359 will be 400. Whereas if we take 670, again 670 lies between 600 and 700, and 670 is more near to 700. Now, being elders, it was easy for us to see if it's near 600 or 700. But for kids, it might be difficult to think if 670 lies between 600 and 700, or is it between something else? How far it is from 700, how far it is from 600. So they start adding, they start subtracting, which takes lot of time. So a new method was created, and we call all this process as rounding off. Okay, now what rounding off process says, let's say we have to round off in tens. So rounding off process, the method of rounding off says that if you have to round off in tens, that means you have to round off the digit at the tens place, then look at the digit at the units place. That means look at the digit on the right of it. If that digit is greater than or equals to 5, then add 1 to the tens digit number. If the number at the units place is not greater than 5, it is less than 5, then do not add 1 to the tens digit number. How? Let's see with an example. Let's say we have 79. Let's place 79 in the place value chart. Okay, now we have to round off in tens. That means we have to find the nearest number in tens. Right? So we have to round off 7. So what will happen? The number at the ones digit will become 0. And what will happen to the number at the tens place? For tens place digit, we have to look at the digit at the ones place. We have to look at the digit on the right of it. So this digit is greater than 5. So when this digit is greater than 5, we will add 1 to the tens digit number, and 7 will become 8. Right? So 79 when rounded off in tens will become 80. If you even think, is 79 really near to 80? Yes, 79 lies between 70 and 80. Correct. And 79 is more near to 80 because it is only one step away. Correct. But it's easy to see in 2-digit number. When we get bigger numbers, it becomes difficult for the students. That's why this method is created. All the numbers, so if you have to round off in tens, make all the numbers on the right of this tens digit number 0. Okay, then for the tens digit number, look at the number on just right of it, that is the unit digit number. If this digit is greater than or equals to 5, then give 1 extra to the tens digit number. So this time 7 became 8. But if this digit was less than 5, then 7 will not get anything and 7 will come down as it is. Let's say we have to round off in hundreds. Then what? Then we will look at the tens digit number, because the digit on the just right of the hundreds number will be tens digit number. So for example, we have 479. Let's put it in the place value chart. 479 will be written like this. So the number that has to be focused is 4, because that's at the hundreds place. So this number will change or will not change. Okay, so first we'll make all the digits on the right of it 0. Right, now to see if 4 will remain 4 or 4 will increase by 1, we will look at the digit on the right of it. That means the digit at the tens place. Now this digit, if this digit is greater than 5, then add 1 to 4. If this digit is less than 5, then do not add 1 to 4. Now here we have 7. 7 is greater than 5. So we will add 1 to 4, and 4 plus 1 becomes 5. So answer for 479 will be 500. Correct. Now let's see bigger numbers. Let's say we have to find the value of 4765 when it is rounded off to the nearest 100. Now again we are talking about nearest 100. Now let's put this in the place value chart. So it will be written like this. Now when you are talking about nearest 100, which digit do we have to focus? 7. So either 7 will change or it will not change. Okay. But what will happen to other digits? Now remember, all the digits on the left of 7 will come as it is, and all the numbers on the right of 7 will become 0. So 4 will come as it is, and the number on the left of right of 7, 6 and 9 will become 0. But what will happen to 7? To take the decision for 7, we will look at the digit on the right of 7, that is the digit at the tens place. Is it greater than 5? Yes, it is 6. It is greater than 5. So 7 will get 1 additional 1. So 7 will become 7 plus 1, 8. And the answer will be 4800. So 4769 when rounded off to the nearest 100 will give you 4800. Okay, now let's take a bigger number. Here, what is the value of 7,89,250 when it is rounded to the nearest 1000? Let's place it in the place value chart. So here we have to round it to the nearest 1000. That means we have to focus on the digit that is at the thousands place, which is 9. So again, the number on the left of 9 will come as it is, 7 and 8 will come as it is. The number on the right of 9 will become 0. But what will happen to 9? For that, we will have to look at the digit on the right of it, which is 2. Now, if this digit is less than 5, then 9 will not get anything. And we can see it as 2, which is less than 5. So, 9 will not get anything, right? 9 will come as it is. So 7,89,250 when rounded off to the nearest 1000 will become 7,89,000. Fine. Now let's say we have to round off a number that is in decimals. So if you remember, how do we place a decimal number in the place value chart? So let's quickly revise it. So this is how the places are written. So on the left of decimal we have ones, tens, hundreds, thousands, whereas on the right of decimal we have tenths, hundreds, thousands. So we will put this in the place value chart 17 decimal 148. Now you have to round it off to the nearest hundreds. That means we have to focus on the digit that is at the hundreds place. So what will happen? All the digits on the left of 4 will come as it is. Decimal will also come as it is. The digit on the right of it will become 0. But what will happen to 4? Again, we'll have to look at the digit on the right of it, which is at the thousands place, which is 8. 8 is bigger than 5, right? So if this digit is greater than 5 or equals to 5, then the number that we have to round off gets additional 1. So 4 plus 1, 5. So our number is 17 decimal 150. Correct. So this is how we round off. I think rounding off is very easy. You just have to put the numbers in the place value chart and then it becomes very easy to round off. Once you are comfortable in just creating this place value chart in your mind, then you don't even have to draw it. You just have to focus on the digit that you have to round off. Which digit do we round off? According to what they have mentioned over here. Nearest 100, nearest tens, nearest thousands, whatever. That digit has to be focused. But all the digits on the left of that digit come as it is. All the digits on the right of it becomes 0. What will happen to that digit? For that, we will have to just look at the digit on the right of it. If that is greater than or equals to 5, this will get additional 1. If that is not greater than or equals to 5, it will not get additional 1. It will come as it is. That's the simple formula of rounding off. Now, let's have some questions. So, just practice these. Pause the video over here. Once you are done, we will discuss the answers. Please pause the video and solve these questions. Thank you. So, as you're back, so I hope you've solved the questions. So, let's see. So, first question says round the following numbers to nearest tens. Okay. So, nearest tens means we had to focus on the number, the digit at the tens place. So, in first one, 13,743. The digit at the tens place was 4. So, 137 came as it is. This 3 became 0. But what about 4? The number on the right of it is 3, which is less than 5. So, 4 will also come as it is. In the next one, 537. The number at the tens place is 3. This becomes 540. Why? Because the number on the right of 3 was greater than 5. So, this 3 got 1 added to it. So, 3 became 4 and 7 becomes 0. 5 comes as it is. 5913 becomes 5910. Next one says round off the following to the nearest hundreds. So, the answer will be for 17,462. It will be 17,500. This time we have to round off the digit at the hundreds place. 9561 becomes 9600. 2485 becomes 2500. Next question is to the nearest hundredths. Now we are talking about the digit at the hundredths place in the decimal. Right? So this will become something like this. So 14.562 becomes 14.560. 9.537 becomes 9.540. 2.485 becomes 2.490. Okay. Now let's move to our next topic, which is estimation. What is estimation? Estimation means getting the idea of the final answer without calculating the actual answer. Now our estimation is based on rounding off numbers, but estimation is a very important part of our daily lives. For example, when we are purchasing a few things at the supermarket, we try to estimate the total cost in our head. Right? So, or we are going to the market, we just have a budget, right? So, when we have a budget, we just estimate, okay, today we might be buying things of 10,000, or we might have to spend 20,000 or 5,000, and we take that much money in our purse, or we arrange that much money before going to the market, right? And estimation also helps us in giving quicker responses. For example, let's say you have to calculate 106 times 53. Now you have only 4 seconds to solve. How will you solve it? They have given you the option 5618, 4618 and 5000. Now if we will start doing 2-digit multiplication with 3-digit, it will take us around 1 minute. But if I estimate, I'll estimate 106 will be around 100 and 53 will be around 50, and 100 times 50 will be 5,000, right? So if 100 times 50 is 5,000, 106 times 53 will be greater than 5,000. It cannot be 5,000, right? It will be greater than 5,000. So obviously 5,000 is rejected, 4618 is rejected. We are only left with the option 5618. So this will give the answer in seconds. Let's take some examples. Now here, our first question is, Ruchika has 899 rupees. She bought a book for 372 rupees. What is the estimated amount left with her? Now we do not have to find the actual amount. We have to find the estimated amount left with her. So that means estimated amount she has. So 899 is near to 900, right? So she has approx 900 rupees. And she bought a book of 372 rupees. Again, 372 is more near to 400. So I will say she bought a book of approximate 400 rupees. 900 minus 400 gives us 500. That means the estimated amount left with her is 500. Or you can say that she has approx 500 rupees left. Now let's see the actual answer. So actual amount she had was 899. Amount she spent was 372. Amount left is 899 minus 372, which is 527. And we know 527 is very near to 500, right? That means our estimation was correct. This means Ruchika has around 500 rupees left. This is not the actual answer. Actual answer will be always a little more or little less. Okay, but this is an estimated answer, that around what amount she has left. Let's take one more example. A toy shop sold 12,565 toys in the year 2010 and 15,729 in the year 2011. Estimate the total number of toys sold in 2 years. Now, if we have to find the actual answer, definitely we will add, which might take us like few seconds. Now, these are two big numbers. We might need a paper also. Correct. So, if I have just few seconds, instead of doing whole calculation, we'll take the estimated amount. So, estimated toys sold in 2010. So, it's 12,565. Now, this is 12,005. So, I will round off 12,565 to the nearest thousands, which will be, so we are rounding off 12,565. So, 2 will become 3, rest will become 0. So, this is 13,000. And the other one, 15,729 will become 16,000. Remember, when you are rounding off, you look at the digit on the right. So, here we are rounding off to the nearest thousands. So, we are looking at the digit just on the right of it. Here I am looking at 7. 7 is bigger than 5. So, my 5 becomes 6. Here I am looking at 5. 5 is equals to 5. So, this 2 becomes 3. Right. So, estimated total amount of toys sold in 2 years will be 13,000 plus 16,000, which is 29,000. Now, let's look at one more example. A factory produces 18,426 cars every month. How many cars are produced in an year? 18,426 times 12 will take few seconds to calculate. So, what I'll do, I'll just round off 18,426. 18,426 when rounded off to thousands will give you 18,000. Correct? And in an year means 12 months. Now, multiplication is with 12 might take few seconds. I'll round it off to, it's a 2-digit number. So, I will round it off to tens. That will become 10. Right? So, 10 times 18,000 is 1,80,000. Right? So, this was quicker. So, estimation helps us in quicker calculation. This is not the actual answer. Actual answer will be, in fact, more than this. This is estimated amount, that we can say that company produces more than 18,000 cars every year. 16 families, let's say, went on a trip, which cost them 21,432. Now, they do not want to calculate the actual amount. They just want to get the idea of how much each family will have to pay. Okay, so when they have to get the idea, they don't have to do a long multiplication or division. They will simply round off the figures. So, 21,432, if you round it off to nearest thousands, that will be around 20,000. Okay, and there are 16 families. Let's round it off to tens. It will give you 20. So, 20,000 divided in 20 families will give us 1,000. That means each family will have to pay approx 1,000 rupees. Again, I am saying it's approximately. That means this is not the actual amount. This is just an idea, or we can say this is estimation. Now, let's move to our next topic, which is factors and multiples. So, let's say if A, B and C are 3 integers, any numbers, such that A multiplied by B gives us C. Then A and B will be called as the factors of C, and C is called as multiple of A, and C is also the multiple of B. For example, if you have 4 times 6, 4 times 6 is 24. So 4 and 6 are the factors of 24. And 24 is a multiple of 4. And 24 is also a multiple of 6. Which also means that if you divide 24 by 4 or if you divide 24 by 6, there will be no remainder. Right? Because if you divide 24 by 6, you will get 4 in the answer. If you divide 24 by 4, you will get 6 in the answer. There will be no remainder. Now remember this fact. This is interesting, and remembering this fact will actually help you in competitions. Now let's understand few facts about factors and multiples. Remember, 1 is a factor of every number, because you can multiply the same number by 1 and you'll get that number. Every number is a factor of itself. We can see the examples. If I have 2, 1 times 2 is 2. So 1 is a factor of 2. 2 itself is a factor of 2. 32 times 1 is 32. 32 is a factor of 32. 1 is a factor of 32. So 1 is a factor of every number, and every number is also a factor of itself. Second, next, a factor of a number. Remember, a factor of a number is always less than or equals to the number. For example, 2 times 4 is 8. So 2 and 4 are factors of 8. 2 is also less than 8. 4 is also less than 8. But if I take 73 times 1, 1 is less than 73. 73 is equals to 73. It can never be, factors can never be greater than its multiple. Factors are always less than or equals to the number. Now, when you multiply a number with another number, the answer that we obtain is called multiple of those numbers, right? So, for example, 7 times 3 is equals to 21. So, 21 is a multiple of 7 and 3. If I multiply 7 with 3, I got 21. If I would have multiplied 8 with 3, I would have got 24. If I multiply 9 with 3, I will get 27. So there can be many multiples of any factor. Let's say we have 5. Multiples of 5 can be multiples of 5. Multiples of 5 means if you multiply a number with 5, you will get a multiple, right? So 5 times 2, 10. 10 is a multiple of 5. 5 times 3, 15. 15 is a multiple of 5. 5 times 20 is 100. 100 is a multiple of 5, and so on. There will be no limit. You can keep multiplying different numbers with 5, and you will keep getting the multiples of 5. Let's take another number, 12. Multiples of 12 can be 12 times 2 is 24, 12 times 5 is 60, 12 times 10 is 120, and there can be many multiples, right? So there are limited factors of a number, but there can be infinite multiples of a number. Now let's take some examples. So here we have to find the factors of 20. What can be the factors of 20? Factors of 20 means the numbers which when multiplied with another number should give us 20, right? So 20 times 1 can be 20, because we know that a number itself is also a factor of itself, and 1 is also a factor of every number. So 20 times 1. 2 times 10 can also be 20. 5 times 4 can also be 20, right? Is there any other factor of 20? No, I don't think so. So factors of 20 are 1, 2, 5, 10 and 20. 20 itself. Let's take factors of 64. So 1 times 64 is 64. 2 times 32 is 64. 4 times 16 is 64. 8 times 8 is 64. So factors of 64 are 1, 2, 4, 8, 16, 32 and 64 itself. So there are always limited factors of a number. Now we will be covering factors in more depth when we will do the topic of HCF and LCM. Our motive here was to make you understand what are factors and multiples. Because now we are going to learn about divisibility test. And for divisibility test, you need to have the understanding of factors and multiples. Okay, now before I start with divisibility test, let's quickly revise what was even numbers. So numbers that can be divided by 2 are called even numbers, right? Or I can say that even numbers always end up with the last digit as 0, 2, 4, 6 or 8. All the even numbers, whatever even number you take, it will either end with 0, 2, 4, 6 or 8. Right? And how do we teach it to the kids? As we did earlier also, that if we have 8 strawberries, we have to put them in pairs. So let's put it there, 2, 2, 2 and 2. Yeah. So that means as we were able to place all these strawberries in pairs, that means 8. These were 8 strawberries. 8 is divisible by 2. So 8 is an even number. What are odd numbers? Numbers that cannot be divided by 2 are called odd numbers. Or you can also say that odd numbers never end with 0, 2, 4, 6 or 8. But then how do we decide if a number is an odd or not? So you can pair them. Dividing by 2 means pairing them, right? Let's say we have 7 strawberries now. Now I'm going to pair them up. So let's put 2, 2, 2. So these are 6 and then we have only 1 left. So we were not able to make the pairs of all strawberries. That means 7 is an odd number. It's not an even number. We were not able to divide it into two parts. In the end, 1 was left. Correct. Yeah, but we also learnt about one interesting fact of odd numbers, that whenever you add any 2 odd numbers, you will get an even number, because then this one strawberry which was left alone gets a pair from the other group. Now let's see what is divisibility test. A divisibility rule is a kind of shortcut that helps us to identify if a given number is completely divisible by a divisor just by examining its digits without performing the long division process. When I say completely divisible, what does that mean? That means that when you will divide a number by another number, there should be no remainder. It should be completely divisible. That means the remainder should be 0. For example, if we divide 3, 2, 4, 5, 6, 8, 1, not rule 2, 3, 2, 4, 5, 6, 8, 1 is a big number. How to guess if it is divisible by 5 or not? If we just to know if it is divisible by 5 or not, if we start doing long division process, it will take a lot of time. So we need a test, so that just by looking at that number, I should be able to guess if it is divisible by 5 or will it give us any remainder. Similarly, if 873575 is completely divisible by 2, or will there be any remainder? So we can answer these questions with the help of divisibility tests, and we do not have to perform the actual division. Now let's start with the divisibility test by 2. Now divisibility by 2 says, divisibility test of 2 says that if the last digit of a number is 0 or an even number, then that number is completely divisible by 2, which means if you divide that number by 2, you will get no remainder. For example, if you have to find 138, if it is divisible by 2 or not, or will it give any remainder? Now, according to this rule, if the last digit of this number is even number, the last digit of this number is 8. 8 is an even number. So that means 138 is completely divisible by 2. It will not give us any remainder. Let's see if this test is correct or wrong. Let's do the actual division to test it. So 138 divided by 2. So 2 times 6 is 12. We will subtract it. We will get 1. Then 8 comes down. 2 times 9 is 18. Remainder is 0. Oh, so that means this divisibility test is correct. That means if in a number the last digit is an even number or 0, then that number will be completely divisible by 2 and there will be no remainder. Now let's see the divisibility test by 3. The divisibility test by 3 says if the sum of all the digits of the number is divisible by 3, then the number will be divisible by 3. So for example, 3426. Now we have to find if 3426 is divisible by 3. Okay, according to divisibility rule, we have to find the sum of all digits of this number. So 3 plus 4 plus 2 plus 6 will give me 15. So 15 is 15 divisible by 3. Yes, we know 3 times 5 is 15. 15 is completely divisible by 3. So if the sum is divisible by 3, then 3426 will also be divisible by 3. Let's test it with the long division method. So 3 times 1 is 3, subtracted 0, 4 comes down, 3 times 1 is 3 again, remainder is 1, 2 comes down, 3 times 4 is 12, 6 comes down, 3 times 2 is 6, remainder is 0. That means the divisibility test is correct. So if the sum of the digits of our number, the sum is divisible by 3, then the number will also be divisible by 3. That means you will not get any remainder. Now let's see what is the divisibility test of 4. Divisibility test by 4 says that the number formed by the last 2 digits of a number, if that number is divisible by 4, or if you have 2 zeros in the end, then that number will be divisible by 4. For example, here we have 3924. Last two digits are 2, 4, 24. So the number formed by last 2 digits here is 24. Is 24 divisible by 4? Now think of the table of 4. So 4 times 6 is 24. So we know 24 is divisible by 4 because 4 times 6 is 24. So divisibility test says that if the last 2 digits, the number formed by last 2 digits is divisible, then 3924 or the full number will also be divisible by 4. Now divisibility test of 5 is very easy. Divisibility test of 5 says if the number ends with 0 or 5, or you have 0 or 5 at the units place, then that full number will be divisible by 5. So for example, again 3940, in here it's ending with 0. So this number will be divisible by 5. Let's take another example, 7385. This number is ending with 5. So this number will be divisible by 5. You can, if you want to try, you can try with the long division method and test if this is correct or not. Let's see the divisibility test by 6. If a number is divisible by 2 and 3 both, then the number will be divisible by 6. For example, again I am taking 3924. So is 3924 divisible by 2? Yes. Why? Because it is ending with 4. 4 is an even number, so it is divisible by 2. Is 3924 divisible by 3? Yes, we have already seen that 3 plus 9 plus 2 plus 4 gives us 18. So and 18 is divisible by 3. Hence, 3924 is also divisible by 3. Now, because it is divisible by 2 and 3 both, that means it will be divisible by 6 as well. Let's see the divisibility by 7. Divisibility test of 7 says, multiply the last 2 digit with 2 and subtract it from the number formed by the remaining digits. Now whatever answer you have got, if that answer is divisible by 7, then the number will be divisible by 7. So for example, let's take 357. So it says multiply the last digit with 2. So 7 times 2 is 14. Now the numbers left, the remaining digits are 3 and 5, so 35. So 35 minus 14 will give us 21. Is 21 divisible by 7? Yes, 7 times 3 is 21. So that means if this answer is divisible by 7, then 357 will also be divisible by 7. Let's take the divisibility by 8. Divisibility test by 8 says that the number found by the last 3 digits of the number found by the last 3 digits of the number, if that is divisible by 8, or if the last 3 digits are 000, then that full number will be divisible by 8. For example, 357,000. Now, in the end, we have 3 zeros. So, if you divide it, you will get no remainder. This number will be divisible by 8. Let's take 586024. Very long number. Long division will take time, right? So, we'll just take the last 3 digits. 024. 024 means 24. Is 24 divisible by 8? Yes, 8 times 3 is 24, right? So, if last 3 digits, the number found by last 3 digits is divisible by 8, then 586024, the full number, will be divisible by 8. Divisibility by 9. Divisibility test by 9 says if the sum of all the digits of the number is divisible by 9, then the number will be divisible by 9. So, divisibility test of 9 and 3 are same. It says if the sum of the digits is divisible by 9, then the full number will be divisible by 9. For example, 458577. Let's add all the digits. So, 4 plus 5 plus 8 plus 5 plus 7 plus 7 give me 36. Is 36 divisible by 9? Yes, 9 times 4 is 36. So, 36 is completely divisible by 9. So, hence the full number 458577 will also be divisible by 9. Divisibility test of 10, very easy. It simply says if the last digit is 0, the number is divisible by 10. Divisibility test by 11. This test says that the difference of the sums of the alternative digits of the number. So, the difference of the sums of the alternative digits of a number is divisible by 11, then the number will be divisible by 11. Let's understand this with an example. Let's say we have a number 290961. So, the sum of alternative digits. So, first we will add 2 plus 0 plus 6. So, first digit, third digit, fifth digit, and second digit, fourth digit and sixth digit. So, the numbers that I have got, the sums that I have got for the alternative digits is 8 and 19. Now, I have to find the difference. 19 minus 8 is 11. Is 11 divisible by 11? Yes, of course. So, the number, the full number 290961 is divisible by 11. Now, let's practice this with some questions. So, check with the divisibility test. We have 2 questions over here and you have to check all these numbers if they are divisible by 3 and 9, 6 and 7. So, please pause the video over here and once you are done, please come back, continue the video and we will discuss the answers. Now, let's look at the answers. So, first question is which of the following are divisible by 3 and which ones are divisible by 9? And our first number is 152. 1 plus 5 is 6, 6 plus 2 is 8. So, 8 is neither divisible by 3 nor divisible by 9. Second, 2889 is divisible by 3 and 9 both. 216 is divisible by 3 and 9 both. 1944 is divisible by 3 and 9 both. And 1884 is divisible by 3. Second question, which of the following are divisible by 6 and which ones are divisible by 7? So, 312 is divisible by 6. 3647 is divisible by 7, 1778 is divisible by 7, 1542 is divisible by 6 and 168 is divisible by 6 and 7 both. So, I hope you understood the divisibility test. If there is any doubt, any questions, any queries, you can always go back in the video and check the divisibility test again. Still, if you have any doubts, you can always ping me on WhatsApp or email me your queries, or you can request for the live session. Now let's look at the next topic, which is prime numbers. What are prime numbers? So prime numbers are the numbers that are divisible by 1 and itself. Only 1 and itself. They are not divisible by any other number. Neither with 2, 3, 4, 6. Not at all. Not with any other number. So they are only divisible by 1 or itself. So when I say divisible, divisible means we can divide something in equal parts. So for example, if you have 5 apples, if I want to divide them in the parts of 2, so 2, 2 and then 1, right? I was not able to equally divide them. If I divide it in the parts of 3, so 3 and then I get 2. I was not able to divide it equally, right? That means 5 is a prime number. So there are many other numbers like 5, 7, 11, 13, which cannot be divided by any other number. What are composite numbers? A number that is divisible by 1 in itself and also by any other number as well is called a composite number. For example, we have 9 apples over here. Now, I can divide these 9 apples in the set of 3, 3, 3. Right. So there are many other examples like 4. 4 can be divided by 1, 4 can be divided by 4, and 4 can also be divided in the parts of 2 and 2. Right. So it can be divided by 2. 6 can be divided by 1, 2, 3 and 6. 8 can be divided by 1. It can be divided by 2. It can be divided by 4 and 8. So all these numbers are called composite numbers. Now, let's say if you get a challenge that you have to find a number, all prime numbers between 1 to 100. How will you find all numbers that are prime numbers between 1 to 100? So there are some key points that you have to remember. Remember, point number 1, 1 and 0 are not prime numbers. These are categorized as special or unique numbers. 2 is the only even prime number. Rest all prime numbers are odd. A number that ends with 5 or 0 will be always divisible by 5. So that number is also not a prime number. Now, there's an ancient algorithm for finding all prime numbers up to given any limit. Okay, let's see what are the steps of that algorithm. So step 1 says write all the numbers from 1 to 100 in the row format, and then cut the number 1 because all prime numbers are greater than 1. Then we have to follow 5 steps. Step number 1, we know number 2 is a prime number. So highlight the number 2 and cut all the numbers which are divisible by 2. That means all the numbers ending with 0, 2, 4, 6 and 8. Step number 2 says then the number 3 is also a prime number. So highlight the number 3 and cut all the numbers which are multiples of 3, such as 6, 9, 12, 15 and so on. Then next number left is 5. So highlight the number 5 and cut all the numbers that end with 5 and 0. Step number 4, we are left with in the first row we are only left with 7. So highlight number 7 and then cut all the numbers that are multiple of 7. Finally, whatever numbers you are left in your chart, all those numbers are prime numbers. Now let's see how to follow these steps. So I have written all my numbers in the row format. So 1 to 10, 11 to 20, 21 to 30 and so on. Now I will cut 1 because we know all the prime numbers are greater than 1. Now 2 is a prime number, so I will highlight 2. 2 is only divisible by 2 and 1. Then I will cut all the numbers that are divisible by 2. That means all the even numbers, because all those even numbers are divisible by 2. So they are not prime numbers. Now I will highlight the next number, which is 3, because 3 is only divisible by 3 and 1. So 3 is a prime number. Now I will cut all the numbers that are multiples of 3, that can be divided by 3. So I will cut 15, I will cut 21 and so on. Then after that we have 5. I will highlight 5 because 5 is a prime number. 5 cannot be divided by any other number except 5 and 1. Now I will cut all the numbers that end with 5 or 0. So they are also gone. Now the next number left in the first row is only 7. So I will highlight 7 because 7 is also not divisible by any other number except 1 and 7 itself. So, and then I will cut all the numbers that are divisible by 7. So 7, so 14, 21, 28 and so on. Now we are left with some numbers like 11, 13, 17, 19, 23, 29, 31. So you can see what numbers are left. Now numbers that are left are the prime numbers from 1 to 100. I hope the method was easy. All these numbers are the prime numbers that we have highlighted now. Now let's move to our next topic and the last and very important topic, very interesting topic. Students enjoy this topic a lot, which is called coding and decoding. Now this topic can be very tricky sometimes, and though being very interesting makes it difficult for the students because it is tricky. But we have to just understand the methods of coding and decoding. Once the methods are understood, it becomes very easy. So we will learn about logical ways of changing an information to coded language and then ways to decode it. So when any letter, word or sentence is written or said in such a way that it hides the actual meaning of that particular letter, word or sentence from others except the desired person, that is called coding that sentence or coding that word. Now besides future benefits, solving questions on coding and decoding also improves our logical reasoning skills and ability to focus on something. So there can be multiple ways by which the information can be coded, and accordingly we have to decode it. So let's understand these ways. So let's say we have to write apple as CRRNG. Now if you notice, what have we done? Here we are replacing each letter with a letter that comes after 2 steps. So A has been replaced by C, P has been replaced by R, L has been replaced by N, E has been replaced by G. Correct. So this method is called letter substitution method. That means you are substituting the letters by any other letter, but there is a method behind it. So we were replacing the letters by skipping one letter. So A was replaced by not B. We skipped the B and we replaced it with C. P. After P we have Q. So we are not taking Q. We are replacing P by R. L is being replaced by N. E is being replaced by G. Now let's see method 2. It is called numerical substitution method. In this method, we assign an alphabet its place value. So these are the alphabets A to Z, and their place values are A is 1, B is 2, C is 3, D is 4 and so on. X is 24, Y is 25, Z is 26. Now to remember this, so that you don't have to count the position of the letters, remember the word EJOTY. You can also call it EJOTY, where E is 5, J is 10, O is 15, T is 20, Y is 25. 5, 10, 15, 20, 25. Table of 5. This will help you in remembering the position of all the letters, because other letters can be near to these letters. So the word English will be written as, so E is at 5, so for E we'll write 5, N is at 14, so we'll write 14, G is 7, L is 12, I is 9, S is 19 and H is 8. right? So if you code the word English, it will be 51471291998. Method 3. Method 3 is patterns in numbers. There can be some pattern in numbers or the figures that you see. For example, here if you see, the first figure has only one triangle. Second figure has two triangles. Third figure has three triangles, and fourth figure has four triangles. Now if someone asks you how many triangles will be there in the 10th position, so we know that according to their positions, the number of triangles are increasing. First one 1, second one 2, third one 3. So obviously 10th one will have 10 triangles. Correct? So there can be different patterns. You will have to analyze the pattern. Now there is method 4, which is called magic square. Now many students get confused in this magic square, but this is very simple and very interesting. The key point to remember about magic square is that the sum of each row and sum of each column and sum of each diagonal is always same. Now I am taking an example of 3 by 3 magic square. 3 by 3 means it has 3 rows and it has 3 columns. Now here if you see, sum of each row will be, so if I take the sum of first row 7 plus 12 plus 11, or if I take the sum of second row 14 plus 10 plus 6, or if I take the sum of third row 9 plus 8 plus 13, each one is giving me 30. Let's look at sum of each column. So first column is 7 plus 14 plus 9. Second column is 12 plus 10 plus 8. Third column is 11 plus 6 plus 13. Whatever you do, every time you are getting 30. Let's see the sum of each diagonal. So first diagonal is 7 plus 10 plus 13. Second diagonal is 11 plus 10 plus 9. That's giving 30. So a property of 3 by 3 magic square is that when you add each row or you add each column or you add each diagonal, every time you will get the same answer. There is one more very important property of 3 by 3 magic square, and that is if you multiply the grid, the middle number of the grid by 9 and then divide it by 3, it will also give you the sum of the magic square. For example, here the middle number is 10. If you multiply 10 by 9, you will get 90 and then divide it by 3. 90 divided by 3 will give us 30. So if you multiply the middle number by 9 and then divide it by 3, even then you will come to know what will be the sum of each row and each column and each diagonal. Now this is how we solve this magic square, just by remembering these two tricks. Now let's solve some questions. So here we have a question. If the word bird, B-I-R-D, is written as E-L-U-G, then decode what will you write for the word P-L-A-T-E? So you have already seen all the methods. So here B was written as E, so we skipped C and D. I was written as L, so we skipped J and K. So every time we are skipping two letters and then writing the next letter. R was written as U, D was written as G. So we notice that every time we are skipping two letters and we are taking the next letter and making the word. So hence plate will be written as, so I have written P, skip Q and R, write S, L will be written as O, A will be written as D, T will be written as W, E will be written as H. So the answer is SODWH. Right? Now let's look at the second question. Second question is based on the magic square. It says complete the given magic square whose sum of each row and column and diagonal is 72. So they have already given us the sum. We already know that the sum has to be 72. So we have 21 here, 25 here, 23 here, 27 here. So 21 plus 23 plus some number will give us 72. So you can calculate that. Similarly, 21 plus 25 plus some number will give you 72. So you can find that number. And when you can also find the last row, this column. Now when you've got all these numbers, you can also find the middle number. So this is the answer that I got. Let's take two examples from Olympiad question paper. I have taken these two questions from the Olympiad 2022. Try to solve these questions. Pause the video over here. Try to solve these questions. Once you're done, please continue the video. We'll look at the answers. So if you're back, I hope you have solved these questions. So let's look at the answers. So here B was changed to E, H was changed to K, and N was changed to Q. So B, H, N was changed to E, Q, N. So again we were skipping two letters. So D, G, D, J, P will be changed to G, M, S. In the last one, we have to find the value of N. We have to find the value of N. That means we have not been given the sum. How will you find the sum? We can see that they have given us the first column. So we can add that column and we will come to know what will be the sum of each column. So if you know the sum of each column, you will also come to know what will be the sum of the last row. Now once you are able to find this number with the help of the diagonal method, you can find the value of N. So 8 plus 9 plus 4 is 21. So 9 plus N plus 5 will also be 21. So 14 plus N will be 21. That means N is equals to 7. And similarly, you can find all the numbers. So yeah, this is the final answer for the magic square. Though we just have to find the answer for N. So N is 7 over here. That's it for today. I hope the session was interesting and knowledgeable. Our next session, which is C7, will cover fractions in detail. So we'll cover the basics, we'll cover types of fractions, we'll cover addition and subtraction and multiplication and division of fraction. So see you in the next session. Take care. Bye.